All right, welcome back to Genius. So in this session, let's talk about literals in Python. Okay. So what are literals in Python? Okay, literals in Python, they are fixed values assigned to variables or used directly in expressions. Yes, it's obvious that we haven't talked about variables. It's obvious we haven't talked about what an expression is. Okay, but literals are fixed values, all right? Fixed values. What it means is that you're not getting the values from variables, all right? So you're getting it that you're getting it directly. Okay, so we have a couple of different types of literals, but literals in Python are fixed values. So we assign these values ourselves. We don't actually get it from maybe a function that is returning a value or a variable. We are reading it from a variable, or we are getting it from an expression. No, they are fixed values that we actually type in ourselves. So they represent constant values and they do not change during program execution. All right. So let me show you something. Here is on our website. So make sure if you want to code along with, make sure you select Python. Okay. So now I'm just going to clear everything here. So when I have a variable like name, okay, if I do something like this, all right, you see this John that I have here is a literal. This is actually a string literal. I can also do age, and I'll say age is 98. This is a number literal, an integer literal. Okay, so these are literals. They are gotten. They are not getting from anywhere, and you cannot change this value, this John value. No. All right. In as much as you can change the value of this variable, the name and age, you can change their values. But this John and this 98, they are not changing. Like these are constant values we give. We know it beforehand. All right. So they are not gotten from expression. They are not gotten from variables. So these are literal values. These are constant values that we assign to variables or expressions, okay? Or we can use them directly in expressions. So now literals are fundamental building blocks in Python programming. They allow developers to represent constant values efficiently. All right. So when you already know the value you want to give to a variable or you want to perform an expression, you already know what they are. So these are literals. So when you understand these literals and their data types, it helps you in writing clean and readable code. Now, we haven't talked about data types yet. So I will be very careful the way I mention them. But the thing is that every value has a data type. Okay, so data type simply means what is the type of this data, right? The value you are actually writing is actually a data. That's what we call it. Remember, computer, everything in there is data. Okay, so what is the type of that data? Now, when I go back to um, the previous example we did, name is equal to John. All right, so that John that is in double quotes, all right, is a string data type. So it is a test. The type of that data is a test. When we say age equal to 98, the type of that data is what? An integer, is a number. Okay? So, types of literals in Python. We first of all take a look at the string literals. Okay? The string literals are sequences of characters enclosed in single, double or triple, single or triple double quotes. I'm going to explain this, okay? But first of all, let me explain. I said string literals are sequences of characters enclosed in single, double or triple single or triple double quote. Look at this example. This is a string literal. They are sequence of characters. You see, we have HELLO. So these are characters. So we have like 5 of them. So this is a sequence of characters. Okay. So when you enclose a sequence of characters in single or double or triple single, look at this one. This one is enclosed in double quotes. Both of them are valid. Both of them are valid string literals. Okay, so you can enclose them in single quote or in double quote. They are sequences of characters. All right, it can be just one character, it can be more than one character, but they are enclosed in either single or double or triple single All right. So when we use this, whenever we use any of the triple, either triple single or triple double, we are creating a multi-line string. So let me take you to our browser where the website. So now we are now talking about string literals. Okay. We have name John, which is in double quote. We could have something else here. We could have surname, and it will be in single quote. All right, it's in single quote. Okay, we can also have, if we want to create something that is multi-line, we can use the triple single quote, the triple single quote. So we can say, let me say this is info, and the info is, I'm going to use triple single quote, or you can see now I am writing this thing in multiple lines. So I can say this is a class where this is a class where we discuss Python literals. Oops. Okay, sorry. Okay, so but before that, I can say, I can just say Python literal. So you can see I have this thing in multiple lines. It is not just in single line. The single or double quotes, they are used to create strings that are in single line. Don't worry, we are still going to talk about strings in details. All right. So, but here we are using triple single quote to create multi lines. And we can also do the same thing with triple double line. So I can just say, instead of if I can just say description, and then instead of single quote, I can use triple. All right. And here I would also end it with triple. So look at it. If I go on and print info, all right. If you print info, let's see what we get. We are going to get them in multi-line the way we have described it here. You can see they are in multi-lines. Even if I put in another line here, like this, if I run this code now, you're going to see, you can see these spaces are included here. They came out here. So if you want to work with multi-lines, you actually use either the single quotes, the triple single quote, or the double triple quotes. Okay. So back to slide. Now, there's also something we call raw strings. Now, the thing is, I don't know, we haven't talked about escape sequences, but don't worry, we are going to be discussing all these things in details when we go to strings chapter. In that chapter, we'll just be talking about strings so that you get to learn everything about strings in Python. But for now, we are just talking about literals, okay? So we can also create raw strings that ignore escape sequences. All right, something like new line character, the tab, the return, carriage return. All right, so now if you can see, okay, let me go to code and show you. So sorry, I'm going to take everything out here. I will just say path. Okay, let me show you something. Let me just say path. Okay, and if I do something like this, hello world. Okay. If I come and put, this is called new line character. Now, if I run this code now and print out the part, if I run this code and print out part, okay, anything that follows this \n would come in a new line. All right. If I run it now, it's going to call, you see, they are not in, normally the way you wrote it, or the way we wrote it is supposed to be in a single line. But because we have used the \n, this \n is called the new line character. Don't worry, we'll talk about escape sequences in details later on. Now, anything that comes here is new line, is on a new line character. If I say tab, we also have tab. Okay, now this tab will just move it one tab forward. You can see there is much space here. Don't worry, we are going to talk about escape sequences, but we have new line character, which is \n. We have tab, which is \t. We also have carriage return, which is \r. Okay. All right, so you can see the space here between the tab and the carriage return, they are actually different. So now the thing is this, what if I want to print something like I want to print this /r, I want to print it out because sometimes we need it when we are working with strings, okay? So what you do is that you use the raw string. So before the first either the single or the double code, you put in R. So when I run this code now, we are no longer going to get this escape sequence here. So let me make it more. If I do new line character, yeah, of course, we'll be expecting the word to come in the new line. But if I run this code now, we are going to be printing the \n together with the hello world. So, but if I remove this R, now this is what we call raw string. If I remove the R, you can see the difference here. You can see the difference, okay? But if I put that means I want to print out that the new line, the \n, I want to print it out. So depending on how you're working with your string, this goes. Okay, so this is what we call raw string. So we can also consider them as literals, okay? So when you print this thing, you're going to have all these things. So sometimes you'll be working with folders, pies, path, and all those things. Then you will need to print out all these, you need them, all these \, okay? So if you want to print \, you use the raw strings, okay? All right, we also have the formatted string, F strings. So it was introduced in Python 3.6 and it allows embedding expression inside strings. I'm not going to go into much details, but we have, like I said, when we talk about strings, we are going to be discussing all these things in detail. So, but the thing is this, in JavaScript, we call this thing template literals, okay? So we have name and age, or these are variables. But in my variable, I want to print them out like this, okay? So let me go to code and make more sense. So I'll go back to our browser, our website, and I have name equal to John. All right. And I have age. Sorry. I have age equal to 30, equal to 98. All right. Then I have another, let's say I want to print, okay, I want to print out my name is John and I am 98 years old. Okay. So I'm going to create another string for that. I'll just call it, let me just call it str. All right. Sorry, this is a keyword. So I'll just call it f. Okay, let me just call it f string. All right, and I will say I'm going to use the formatted string. So for the formatted string, just like the way we use the raw string, we started with R. Just start with F, then put in either your double quote or your single quote, anyone. So, but right now I'm going for single quote. So inside this single quote, all right, I'm not going to say my name is. Now look at what I'm going to do. I'll put this bracket. I will now put in name, which is the variable, and I am age years old. All right. So now, if I go on and print this formatted string, FTL, okay, you're going to see we are now going to have my name is John and I am 98 years old. So this is called a formatted string. You see, I am replacing, of course, this is an expression, all right? Whatever you're saying here is an expression. So Python is just going to evaluate it for me and include it inside the string. So what you do is you need to start with F. If I remove this F now, I think it's just going to print my name is name and I am 8 years old. All right. So it's not, you can see, it's not a formatted string now. But if you start with F before either the single quote or the double quote or the triple single quote or the triple double quote, it will be formatted. So Python will say it as, okay, since you started this thing with F, that means anything I see inside bracket, I'm going to assume it's an expression and I'm going to evaluate it. Don't worry, we'll have a separate session where we'll talk about all these what expressions are and stuff like that, okay? So when I run this code, we are going to get the formatted string. All right. So that's what we have here, okay? So we also have the numeric literals. Numeric literals, they represent numbers and they can be of different types. So if you want to represent numbers, you use numeric literals. So examples are the normal integer literal, 42, the decimal. So it also supports binary literals. So if you want to write a binary literal, you just have to, of course, you know the binary value, okay? Then you just have to preface it with 0b, okay? So this 1010 now is 10. So let me show you here. So, of course, this age here is a numeric literal. The age here is a numeric literal. So I'm going to take everything out and I'm saying, um, I can just say num is equal to, so this is a numeric literal now. The number can say 23. All right. So if I want to print out decimal as in binary number, I will preface it with 0b, then I cannot say 1010. So if we go on to print this num, let's see what we get. If I print num, we are going to get 10. It will just print out 10 for us because 1010 is the binary representation of 10. So, but you have to preface it with 0b so that Python will know that yes, you're writing binary. Okay. So you can also go with octa. Octa, you have to preface it with 0o. All right, 0o, that's octa. And for hexadecimal, you're going to preface it with 0x. All right. So I'm not going to tell you, I'm not going to be teaching you binary, octal, or the hexadecimal. So if you already know them, if you want to write them, all you have to do is to preface with 0b for binary, 0o for this decimal, sorry, 0o for octal, and then 0x for hexadecimal. We also have float literals. You know, when you have decimal numbers, all those ones in mathematics, those things we call decimal numbers that have points, 3.14, 3.34, 3 point, anything that any number that has these fractions like this 3 point something, we call them floats here. Don't worry, we are going to be discussing these things in details in separate chapters. So we also have the scientific literal. So if you want to represent 10 raised to power 3, all right, all you have to do is say E3. So let me show this example here. Let's say I want to represent 10 raised to, I want to do 1000, all right? You know that 1000 is 10 raised to power 3. So this 1000, I can just say 1E3. And if I run this code now, it's going to give us 1000. All right, it's going to give us 1000. So, but it actually return it in the floating points. Okay, so this is scientific. All right, so now there is also something we call complex literal. All right, they stop with they are prefix, no, they are suffixed. All right, so they always have this J at the end of it. So you can say 3 plus 4J. All right. Now, this complex literal is something we are going to have to discuss later on. But just know that we also have complex literals, and you can say 4J, 3J, whatever J it is, okay? But you have to end it with J. All right. So we also have the Boolean literals. Boolean literals are what we use to represent true or false. Okay, when you ask somebody, is it raining? The person would either answer true or false, yes or no, on, off. All right, true or false, on, off, yes, no. All right, all those things that just have two values, all those things that they can either have one of two values. So here, the Boolean literals, they represent true or false, which are internally stored as integers, 1 and 0. So true is 1, false is 0. So let's say another example we have there is Python fun? It's left for you to say true or false. Do you like Python? It's either true or false. All right. Is the sky red? Of course, the sky is not red. So it's either true or false. So which is false? Okay. Now, whenever you use true, whenever you do anything like true plus 1, you're going to Python is actually going to do. Look at let me show you an example here. If I say true plus 2. See what Python is going. Whenever Python sees an expression, so this is what we call an expression, okay? Don't worry, we'll talk about that later on. Whenever we say true plus any number like this, whenever we do any mathematical operation like this with true or false, Python is going to assume that this is true is 1 and false is 0. So if I run this code now, we are going to get 3. Okay, we are going to get 3. If I say false like this, all right, 0 plus 2, because false is 0. So 0 plus 2 is what? 0 plus 2 is 2. So we'll get 2. All right, because false is 0. All right. All right, so you can see here, false is 0 and true is 1. So whenever you're doing a mathematical expression like this, just know that true is 1, false is 0. All right. So we also have another literature that we call none. All right. Don't worry, we're going to have more details about this. Okay. So the non-literal is a special literal that represents the absence of a value. So when you have a variable and it doesn't have a value, you give it none. So in other languages, it is null, but for Python, it is none. Okay, so none is actually a literal value. So I can go on and say, let's say I have a variable that does not have any value. So I will just say it is none. So if I print this thing, now the value is going to be none. All right. So don't worry, we're going to explain more about this later on. So we also have special literals. Now Python uses underscore for readability in large numbers. So when you have a number like 10 billion, all right, when you write that 10 billion, for readability, it will be hard. So you can actually separate all those three zeros, all right, with underscore. So if I go now and say, if I say this number is 1, 2, 2, 3, 4. Now, looking at this thing, it's hard to read. It's very, very hard to read. But you can actually separate the three zero, oh, sorry, with underscore, not hyphen or underscore. So with this now, it is more readable, right? You can see now it's more readable. So readability is actually a very important thing in programming. So you can see that it's very, very readable. At least I can know, okay, this thing has how many, has four, three zeros, okay? So I will know that this thing is, 3 zeros is 1 billion, 4 will be 1 trillion. So if I run this code now, it's just going to print it out for us. But for readability's sake, all right, for us that are reading this code, we now understand what this thing is. So you can use underscore to separate them like this, and it will be more readable for you and other programmers. All right. So we also have collection literals. Now, collection is actually something we are going to be talking about later on in separate chapters. But we also have their literals because we can use their literals to create them. So a list literal in Python is a way of defining a list using square brackets with elements inside separated by commas. So a list in Python is something like arrays in other programming languages. All right. So they are ordered, they are mutable and can store multiple data types. Don't worry, we are going to talk about list in details. All right. We are going to talk about list in details. So when you have something like this, you have a list of fruits. So this is how you create the literal. All right. You put them in brackets like this. All right. So this is a list literal. Don't worry, I'm not going to be going to do examples or anything here because we are going to be having a separate chapter for all these things to teach you how to create them and everything. But these are types of literals that we also have. So we have list literal, we have tuple literals. Tuple literal is a way of defining tuple. We have something we call tuple, we have something we call list, we have something we call dictionaries. They all have their ways. We have the ways of creating them, and we are not going to be discussing what they are here, but in the separate chapters, we'll be discussing them in details. So tuples are ordered immutable, while lists are ordered and mutable. Tuples are ordered and immutable. So, but don't worry, I'm not going to be discussing that here, in order not to get you confused. But in later chapters, we'll be discussing them in details. So dictionary literals, we also have dictionary literals, and these are key value pairs separated by commas. So dictionaries are unordered. List and tuple, they are ordered, but dictionaries are unordered. They are also mutable and they can store data in key value pairs. Don't worry, we're going to be teaching you all this in separate chapters. So we have dictionary literals. How do you create them? You create them using the curly brace. For the list, you create a list literal with with brackets and put in the elements inside of it, with separated by commas. For tuple, we create them with parentheses and putting the elements separated by commas inside it. For dictionary literals, we create a literal with these curly brackets. Okay, so we also have set literals. All right, so it is a way of defining using curly braces with comma separated elements. Now they are unordered, okay, and they are mutable and they do not allow duplicate values. Okay, so this is like a brother to list or tuple, but list and tuple can contain multiple duplicates. All right, but set does not contain duplicate values. All right, so don't worry, when we talk about them in detail, you're going to understand better. Okay, so we also have empty collection literals. So if you want to create an empty list, you just have to put only the bracket. There is nothing inside of it. For the tuple, you just parenthesis, nothing inside of it because it is empty. And for the dictionary, you create with curly brace like this, empty. But for the set, if you want to create an empty set, you use the set method. All right, you use the set method because if you use the ordinary curly brackets, they would curly braces, they would actually mean that you're creating a dictionary. So, but don't worry, we have a separate chapter where we teach you all these things separately. But here we are talking about literals. And what are literals? Literals are constant values, all right, that we actually assign to variables or assign in expressions. Okay, so ladies and gentlemen, this is where we drop it for today, and I'll see you in the next section.